First, we will want to give you a brief introduction to scanning. Then we will learn more about port scanning. Do you know what protocol is being used by most network services and programs? It's TCP/IP.
I knew that. Services listen through the ports. A client can contact the service and establish a connection. The intent could be to transfer information or request services. So let's turn our attention to our point of discussion. When we scan the ports on a server, the port returns a response. In fact, it is indicating that the port is open and a service is listening on it. That's a short definition of port scanning. In this course, we will also discuss port scan tips, ping, TCP/IP stack, three-way handshake, mechanism, TCP flags, Nmap TCP connect scan, half-open scan stealth scan, and UDP port scan. We will also introduce a few scanning tools. Then we will briefly talk about packet crafting, OS fingerprinting, and TCP fragmentation scanning. We will conclude with a few recommendations on countermeasures you can take to prevent any hackers getting onto your vulnerable ports.
So we're going to quickly explain what ports are. Ports are a software abstraction used to distinguish between communication channels. Ports identify specific applications in use on a single machine. What then do you think is port scanning? So port scanning is the act of remotely testing numerous ports to determine what state they're in. In other words, we're trying to see if they are open. Most often found status of a port is that it is in an open state. What this means is that the application is listening and accepting connections on the port.
PortScan is a simple software used to distinguish between communication channels. But before we proceed any further, let's compare ports to IP addresses. IP addresses are used to find the machines in a network. Ports are used to find a particular application on a single device. So you can have many ports on a machine for an IP and address. Let's talk more about common ports. For HTTP URLs, the web browser will, by default, connect to TCP port 80. If HTTPS protocol is specified, the browser will try the port 443 by default.
Now, network scanning is a procedure for identifying active hosts on a network, either for the purpose of attacking them or for network security assessment. Scanning procedures such as ping sweeps and port scans return information about which IP addresses map to live hosts that are active on the internet and what services they offer. Another scanning method, inverse mapping, returns information about what IP addresses do not map to live hosts. This enables an attacker to make assumptions about viable addresses.
I will be referring to the Nmap tool as well. Nmap is a free open source port scanner available for both Unix and Windows platforms. It has an optional graphical front end, Nmap FE, and supports a wide variety of scan types, each one with different benefits and drawbacks. It can also be used for network exploration and security auditing. It was designed really to rapidly scan large networks, although it works fine against single hosts. Nmap uses raw IP packets in different ways to determine what hosts are available on the network, what services and application name and version that those hosts are offering, what operating systems, what type of packet filters or firewalls are in use, and many other characteristics.
So while Nmap is commonly used for security audits, many systems and network administrators find it useful for routine tasks such as network inventory, managing service upgrade schedules, and monitoring host or service uptime. It's important to understand the types of scans that are available. There are, in fact, two main types that are mostly used. They are TCP Connect scanning and SYN scanning. SYN scanning is also known as half-open or stealth scanning, and we'll see why it's called that a little later.
I can't wait. Unix sockets programming uses a system call named Connect to begin a TCP connection to a remote site. If Connect succeeds, a connection was made. If it fails, a connection could not be made. It could be because the remote system is offline, the port is closed, or some other error occurred along the way. This allows a basic type of port scan, which attempts to connect to every port in turn and notes whether or not the connection succeeded. Once the scan is completed, ports to which a connection could be established are listed as open and the rest are said to be closed.
So this method of scanning is very effective and provides a clear picture of the ports you can and cannot access. If a Connect scan lists a port as open, you can definitely connect to it. There's a major drawback to this kind of scan. As we said earlier, it is very easy to detect on the system being scanned. If a firewall or intrusion detection system is running on the victim, it attempts to connect to every port on the system will almost always trigger a warning. With modern firewalls, an attempt to connect to a single port which has been blocked or has not been specifically opened will usually result in the connection attempt being logged. Most servers will log connections and their source IP, so it would be easy to detect the source of a TCP Connect scan. So for this reason, the TCP Stealth Scan was developed.